Now, if we remember from yesterday, we stopped right here. The general form is a squared minus b squared is a plus b times a minus b. So anytime you have two squares and it's a difference, you figure out what was squared, and then you plug it into this format, 2m plus 9, 2m minus 9. It's a very nice, simple thing that happens when you have a difference of two squares. Very good. Now, you want to look for them. Sometimes when you look for them, though, you don't see them as obviously. This was already in your notes, so I'm not waiting for anybody on this slide because it was from yesterday. Already there.
Oh, this?
No.
You were there.
It's already there from yesterday. It's already written in your notes. I was reviewing, going back over it. You were just looking in your notes. So we're moving on to this one, which is the next example. We need to always look for common factors first.
Two.
Here we have a 2. So we start off always, if there are common factors, bring them out first before you try something else. So 2 goes into 50 how many times? 25. And 2 goes into 72? 36 times. So we bring out our greatest common factor, and then you look and you see, is there anything else I can do? Now, in this case, we do have a difference of two squares. Differences of two squares are very important. What is squared here?
5a and
What times itself gives you 25? So we have 5a, and what times itself gives you 36? 6. So these are the two things that are squared. Okay, 5a times 5a is 25a squared, and 6 times 6 is 36. It's a difference of these two things squared. Okay, so in our little format,
yes, in a little format,
you take these two numbers, the things that are squared, and you do 5a plus 6 and 5a minus 6. Very nice, little, simple thing to do. Not too terribly much work when you have a difference of two squares. How can you, on your calculator, tell, if you don't remember all your perfect squares, how can you tell if it's a perfect square? What do you think, Alexis? Good. Use the square root button. If it comes out even, you've got a perfect square. And that number is your number that goes here. Okay, so look for common factors first, because at the beginning this isn't the difference of two squares, is it?
No.
But once you factor out, you have a difference of two squares. What we're doing is we're factoring these things completely. You keep factoring until there's nothing else you can do. Philip?
What if it's not a perfect square and then you put prime?
If it's not a perfect square and there's nothing else you can do, you put prime. Yep.
I have a question.
Yes.
If you can reduce, but then when it reduces to isn't a square root, what would happen with that time?
If you can reduce,
But what you
then
reduce to
if it won't work that way. If you have a perfect square and a perfect square, and it's not going to reduce to not being a difference of two squares. Okay, it can't happen. I don't think. Do you have one in mind? Okay, let's take a look at that one. Read it to me.
36x squared.
It's calm.
Minus 35 squared. That's 6 squared.
Oh, I see, because you're looking at 2. Because you pull it out by 2 and then it doesn't turn out. Okay, yeah, I'm sorry. It can't happen. All right, so if you see this perfect squares, stop. Stop. Actually, we can. Let's bring out what's in common.
6, 2 and 2.
2 and 2. Let's do that. I want to show you because this is kind of a long way about it. Are we done yet, or is there more in common? There's more. What is in common?
Oh, you could have done 4.
Another 2, right? So we bring out the other 2, and you'll get a 4. And sometimes you'll just see it like that. So you may not see it at once, but as soon as you bring out the one thing, the other one becomes obvious. So this is really 4. If you saw the 4 from the beginning, you wouldn't have to go through all this. So this one actually does reduce, again, to a difference of 2 squares. And you should always bring out the common factor first. And like I say, if you get halfway through and see, wait, I missed one, finish it. Bring out everything. And then what is it that is squared? That we have
3 and 5.
3 squared, 3x and
5.
5y. 3 times 3 is 9. 5 times 5 is 25. It is a difference. So we do 4. And this is 3x plus 5 and 3x minus 5. Now if you started from the beginning, 5y. Thank you. Now from the beginning, if you had seen 6 and 10, you would have 6x plus 10y and 6x minus 10y, but each one of those could have a 2 brought out. So you really should pull out your common factors first.
And it would end in that.
It ends like this. All right? This is it right here.
So, would it be possible to put it like that first and then simplify after?
You can simplify afterwards. However, people usually tend to miss them if they wait to simplify it afterwards.
Mr. Daddy.
Ladies first. Yes.
For number 3, is the answer 4n plus 5 and 4n minus 5?
4n, because I'm
Like, is this?
Because I'm actually kind of in the middle of teaching the lesson on it, so you guys are jumping to individual problems. Which one are you talking about?
Number 3.
4n plus 5, 4n minus 5, yes. Please don't listen to me. I want everybody right now to stop doing the problems on the worksheet so that you can pay attention to the lesson so that when you have to do all of them, you can actually do them. Because I can't... Okay, so we did that one. All right. We always want to see if we can factor more. So this is kind of a long problem, but I want to make sure we do this one. First look for what's in common across all of them. Which is x and what else? 4.
Oh yes, 4. Where'd you get the
4 is in common because 4 goes into 4, 8, 4, and 8. X, there is an x in all of them. So we bring out a 4x. 4x times x cubed plus 2x squared
minus
minus 2.
No, it's still 8.
Minus 2, because that all goes in, right? So after we have this one, we have to see what we can do next. Okay? We are going to have to group it. Okay? We're going to have to do this part by grouping. What goes into x cubed and 2x squared? X squared times x squared times x gives you x to the third. X squared times 2 gives you 2x squared. Now, right here, this one's kind of hiding a little bit, but there is a 1. 1 times x plus 2. Okay? Okay, don't worry about these other parentheses. I'm just making it set apart so we don't lose our 4x. So then this turns into
4x
X squared minus
x squared minus 1
x squared minus 1
times x plus 2.
times x plus 2.
Right.
Now, you always want to check to see is there anything else we can do. This one's brought out. This is factored completely. What about this one?
This square.
But
This
there's
one-
still other stuff.
This one here,
You still
look,
have to go to them.
Grace, right here, I'm saying yes, there is other stuff. Right here,
Yeah.
this one's a difference of 2 squares.
Exactly.
What
We can still
here,
factor it out.
1.
x is the 1, what is the square root of 1?
1.
1.
See?
So-
4.
4x, and then this one can break down.
So units of 3 parentheses.
Yep,
Nice.
this is factored completely. So x squared minus 1 turns into x plus 1 plus x minus 1. Now it's done. You always have to check for everything. You have to make sure you have factored completely and that there is nothing left to factor. Okay? Is there anybody still writing? Alright, I just want to give you a couple of things. Here's just a last note. The sum of 2 squares does not factor. So for example, if I have x squared and 25, that one's prime.
What do you mean?
Plus, it's a sum.
Prime.
A sum changes it. If it's a difference, it does. If it's a sum, just know.
Alright.
No, look, sum. They're perfect squares. They're both perfect squares. Listen to me, you've got to get this. This is a common mistake.
Right.
It's a sum of 2 squares. It's not a difference of 2 squares. The sum of 2 squares doesn't factor. So you have this one. Here's a perfect square. Here's a perfect square. That one doesn't factor. This one. Here's a perfect square. 27 is not a perfect square. So this one also doesn't end up working. This one also turns out to be prime. So just keep in mind, you have to have those things worked out like that. And hold on just a minute. I just want to see what I've got here. Oh, okay. Okay, so just the sum of 2 squares doesn't factor. Okay, now, at this point, okay, at this point, we have 1 minute left, but I did finish this lesson. I could do a couple more examples, but I did finish it. The difference of 2 squares, worksheet 8.5 is due Monday.
Or Tuesday.
Listen very carefully. Number 8.6.
Yeah, perfect square is like 25.
Hey, yo, Giovanni.
Alright, I'm not done talking, but you apparently
Why is
are talking over me. Knock it off and listen.
Because it's a sum, so you can't do x plus 3. No sum.
8.6, we're gonna finish that lesson. We're gonna do that lesson on Monday, which puts us back a day. Tuesday will be our review day, Wednesday will be your quiz. Okay, instead of having the quiz on Tuesday, we're having the quiz on Wednesday, but let me give you a heads up on that. Assignment 43 reviews everything. On Tuesday, both assignment 43 and worksheet 8.6 will be due. Now wait, before you go anywhere, I'm not done yet. Last instructions. If for whatever reason we're not in school on Monday, you're responsible to watch the lesson online. Alright? You are responsible. The homework will still be due. Oh, okay. Actually, yeah. Okay, so the recorder's on. And today in geometry, we're looking at exploring ratio. In chapter 8, we're skipping chapter 7 for those that aren't here. Chapter 8 Now, a lot of you probably remember from your past, even in junior high, what ratio means. You don't have to write this definition, but a ratio is just a comparison of two numbers by division. In other words, it's a fraction, and you always reduce fractions. So that means that you always reduce ratios. Okay, so we're thinking fractions when we're thinking ratios. Sometimes they can look a little different, and we'll get to another notation in just a second. Here's the information for our first example. A class has 8 girls and 10 boys. Okay, there are several different ratio questions that I can ask you regarding these 8 girls and 10 boys. Okay, the first ratio question is if we need to write the ratio of boys to girls. So we're comparing the number of boys to girls. So we're going to write it as a fraction. What number goes in the numerator of our fraction? Boys
Numerator.
to girls. So
8 boys.
10
Girls.
boys
Then
to 8 girls. It does matter which goes in the numerator and which goes in the denominator. If it said girls to boys, we'd have a different number. So this is 10 to 8, but it can be reduced. It can be reduced to 5 over 4. Now, if you're not good at reducing fractions, you can always use your calculator, 10 divided by 8, and then change it to a fraction with your math frac button that we've done before. Okay? So, 5 to 4. You can also write a ratio like this, 5 dot dot 4. That's the other way of writing this ratio. I'll accept either. Most of the time you'll write a fraction.
Isn't there another way to write it?
5, 2, 4.
5, 2, 4 with the word 2.
Yeah.
We'll just leave it like this for now. So girls to boys, that will look differently. What goes in the numerator for this one? 8. Same numbers, 8 to 10. Girls to boys, 8 to 10. So then we reduce that fraction, 4 to 5. 4 girls to every 5 boys. Again, dot dot is not meant to be. 4 dot. So 4 to 5. Same information, we could ask the ratio of the number of boys to total students. So the number of boys is 10, and 18 is our total students. So sometimes you have to do a little bit of math in this problem to figure it out. 10 to 18, so that would reduce to 5 out of 9. And we could say every 5 out of 9 students is a boy. We could say every 4 students, for every 4 girls, there's 5 boys. So the sentences would sound a little bit different depending on what the original question says. Okay, so the ratio of boys to total, 10 to 18, so it reduces to 5 ninths. Okay, sorry, that's just a blank slide. All right, sometimes when we want to reduce units have to be changed in order to reduce this should say ratio. Okay, so sometimes units must be changed in order to reduce a ratio. Right here I just have some things. They should be common to just about everybody besides Harry and Grace because they weren't raised on the English system. These are metric. This looks real familiar. Okay, 100 centimeters to 1 meter. That'll be harder for those of us who aren't as used to metric. 1,000 grams to 1 kilogram. But for Harry and Grace's benefit, 12 inches equals 1 foot. And 16 ounces equals 1 pound. When you see in the homework, you may see converting pounds to ounces, or inches to feet, or feet to inches. So these are the ones that you'll need for this homework. Okay, 12 inches is 1 foot, 100 centimeters is 1 meter, 1,000 grams is 1 kilogram, and 16 ounces is 1 pound. Okay, so what do I mean by that? we want, your direction would say rewrite so the numerator and denominator have the same units, then reduce. So here's a nice ratio. Okay, 20 centimeters to 2 meters. Do they have the same units? No. But in order to make this ratio reduced, we have to click them so that they have the same units. Okay, so it's always easier to go from a bigger unit to a smaller unit. Which is bigger, meters or centimeters? Meters. It's always easier to go up than it is to go down. In other words, there are more centimeters, that's what I mean by going up, than it is to go down. So we're going to leave our 20 centimeters alone. And how do I change 2 meters into centimeters?
Moving over, wouldn't that be 10?
How many centimeters are in 1 meter? 100. Just right up here, I have reminded you 100 centimeters in 1 meter. So in 2 meters, shouldn't there be more? Yeah? So 200, right. You're going to multiply times 100. And that gives you 200. So 2 meters is 200 centimeters. Okay? 2 meters is 200 centimeters. It says rewrite so they have the same units. Now we have the same units.
Is that a 2 or a 1? Oh, 2.
This is a 1, this is a 2. Yes.
What about the numerator? Just move it over.
The numerator is, we want them to be the same units. So if I'm converting the denominator to centimeters, this one can get left alone because they have to match. Okay, they need to match if it tells you to make them match. Okay, so now 20 over 200 reduces to 110. The units have canceled, so 1/10 is our answer. So they have to have the same units first and then reduce. So that's one thing that you can do with ratios. Question?
Could you just divide that and make 10 and then add the 1? Or just don't
No,
have to
you
go-
can't because this one just happens to work that way because it's 100, but it may not work this way. Like if this was with grams and kilograms, you have 1,000, you'd get something completely different. And it doesn't just flip the numerator and denominator. It happened to look that way on this one, but that doesn't just happen. You have to actually do the work, convert one of them so it matches the other, and then reduce. All right, let me give you another example here. 2 feet and 27 inches. 2 feet to 27 inches. Now, which is smaller, feet or inches? Inches are smaller, so in this case, we want to make feet into inches. So, how many inches are in 1 foot?
12.
12. We had that on that little reminder that I just wrote for you. So that means for each foot we have 12 inches. So I need to do 2 times 12. And so 24 inches is 2 feet. 27 inches here. And then we can reduce. What goes into numerator and denominator? 3. So this is 8 over 9. Okay, so this one's a little more obvious, Imani, as far as not just being able to divide and then flip it. That just was a coincidence in that other problem. All right, so you convert to the smaller units and then reduce. Okay, whichever one is the smaller unit, leave that one alone. All right, everybody have that? Okay, we're going to move right along. This is proportional. If 2 ratios are equal, they're called proportional. Okay, and a proportion looks like this. One fraction equals another fraction. Fraction equals another fraction. On SATs or standardized tests, you might encounter this notation. I say might, I don't know if they're still using it or not. I don't prefer it. I like the fraction ones better. But notice this means A over B, this means C over D, and then this set of dots means it equals. So this really means A is to B like C is to D, or A is to B as C is to D. And that's what those dots are really meaning. But like I say, I much prefer the fractions and the equals, and that's what we're going to emphasize. But I want you to see that. Shouldn't it say what? A proportion looks like this is a proportion. Question, Alexis? Oh, right here? Good. Okay, so I'll let you say that one. We're looking for what's missing here. These are equivalent fractions, came from eons ago when you learned these things, Alexis. What does go in the question mark goes? 6. How'd you get that?
5 goes into 15 3 times, so you multiply 2 times 3.
Good. So she remembered that this is times 3, so if you multiply numerator times 3, you have to multiply both numerator and denominator times 3, so that gives you 6. Okay, so these two are proportional. 2/5 is proportional to 6/15. Yes.
Can you cross multiply these?
That's next.
Oh.
Yes. Yeah, absolutely, yeah. If we're going to solve them, in general, usually we'll end up using cross multiply, but I need to teach you the cross product property, which you probably already know. We use it a lot, and the reciprocal property, which we're going to mention, but we're not going to use as much.
Reciprocal.
Cross product property says that if A over B equals C over D, then cross products are equal also. AD equals what? BC. Okay, so AD equals BC. Cross product property. We use that to solve a lot of the problems where we have fractions being equal to each other. The reciprocal property says if A over B equals C over D, what are reciprocals?
B opposite, right?
Yeah, B over
B over A is equal to
D over C. Flip. Yep, that's it. So that's our reciprocal property. This one's more useful. Cross products we're going to use more to do problems. We can use this one. It's just harder to find a place where you can. Okay. All right. So we've got these two properties that we're going to use heavily in order, well, the first one, in order to find answers to questions. Alright, so solving using proportions. This one's not as obvious as far as finding something you can multiply times 1. So this is where the cross products comes in. So 4 times 7 cross this way, 28 equals 5x. Divide both sides by 5. So x equals 28/5. You can give an answer as an improper fraction, or 5 3/5 as a mixed number, or 5.6. I'm going to prefer the fractions. However, if the decimal ends, you can go ahead and give the decimal. Okay? Like if you had 5.33333333, just write that with 5 in the third.
Wait a minute, what? 5.6, isn't that 6 repeating?
No, 6 repeating is not the same as 5.6.
No,
6
I mean,
repeating is 2/3. 3/5 is just
Oh, yeah.
0.6. So they're two different numbers. You're not the only one to ask. Someone asked in the morning class too. This is an ending decimal. 666666666666666. On and on and on. That's a repeating decimal, and they're different fractions. Okay. All right. Let's see if we can get this one in. Once again, cross multiply. So we bring this around, and we get 3y. We bring this around,
2y times 4
and
plus
we get
4.
2 times y plus 2. So don't forget to distribute there. 3y equals 2y plus 4. And then subtract 2y. So y equals 4. Okay, so that's a nice little problem to do. Antonia?
Will we just find y or x, whichever case, or will we put it in the problem itself?
It would depend on what the question asked. Usually, like this one would say find, we'll give it a direction, find y.
Okay.
Okay, then you know what you're asked to find. If they ask what would the proportion be, then you could plug it in and do that, but this is just find y. All right, I think I'll probably need about 10 minutes when we get back, but